So let's go ahead and solve the next problem. A W6 cross 15 steel column is 24 feet long and is fixed at its ends as shown in figure. So this is the column that is 12 feet over here and 12 feet at the bottom level. And so the top is 24 feet and the column is fixed at both the ends, like at the top and at the bottom. Its load carrying capacity is increased by bracing it about the YY or the weak axis using struts that are assumed to be pin connected to its mid height. So there are some supports that are being provided at the mid height of the column so that the column does not buckle at the, like, if the column is obviously 24 feet high, so it is most probably going to get buckled. So to avoid that, they have provided some horizontal supports to it. Determine the load it can support so that determine the load it can support so that the column does not buckle nor the material exceed the yield stress. Okay. So what they want is to determine the overall strength of the column and not allow the column to either yield by excessive deflection or by buckling, or not yield through the yielding. Okay. So we don't want anything to happen to the column basically. So we want the least stress or the least load that it can carry. uh, the EST, or the modulus of elasticity of steel, is 29 in 10 to the power 3 ksi, and sigma y is equal to 60 ksi. In the previous question, the sigma y or the yielding stress was 36 ksi, and over here it is 60 ksi. Now, there are two conditions that are being discussed over here. One is that the column is supported in the YY axis only. Like the column is having support in the YY axis, and in the XX axis it is not being supported, which means that the column, if it has to buckle, it would buckle throughout the height in the XX axis. So the bara chikam the condition de da fix de land fix de pade direction ke te pura pura tavedeshi को because the bara ulandi fix they know they was सिर्फ half length पूरे बतावी लका बकल की गिबा ठीक था. In this case क्योंकि the column they side नो the support मिलाओ शवे दे हो दे सके दे bara ना हो पूरा नशी तावे दे हो because this is hinge connection, so it can buckle from this height to this height, which is 0.7 into L. ठीक है. 0.7 into 12 is equal to 8.4 feet. जरा ऊपर रखा लम जा वापस रिज्यूम को ठीक था लग वेट ओके. Okay जी sorry. So where were we? Okay. So the whole column is supported in one direction only. It means that in the other direction, it the whole length can start buckle. and in this direction where it is being supported, the buckling length is 8.4 feet, and in the other direction, the buckling length is 12 feet. Okay. So the solution. The buckling behavior of the column will be different about the x and the y-axis due to the bracing. Okay. The buckled shape for each of these cases is shown in figure. So as I mentioned earlier, this figure, the effective length for buckling about the x-axis would be 0.5 into 24 feet is equal to 12 feet, and in the other case, it would be 0.7 into 24 divided by 2, which is equal to 8.4 feet. Okay. So 8.4 feet or 12 feet is the buckling length they in the y-axis and z in the x-axis respectively. The moment of inertia for W6 cross 15 are determined from the table in Appendix B. We have Ix is equal to 29.1 inch 4 and Iy is equal to 9.32 inch power 4. So again, these I are taken from the AISC LRFD manual. So obviously we don't need to go ahead and find them again. The P critical would be pi square EI divided by KL square, where E we already know that, I we have got that from the appendix, divided by K into L whole power square. So we already know that, we have calculated that. So in conclusion, the P critical in X direction is equal to 401.7 kips, and P critical in Y direction is 262.5 kips. Now, I would like some of you or any one of you to tell me about which load is going to govern over here, 401 or 262.
y-axis की सब्जी अगर लोड डेढ़ x-axis की इख्तियार डेढ़ लाल चलोर
ضبط هنا رسیدم تاسو یو خبرو کې صرف
x-axis
x एक्सिस वाला भगवान कई यानी कि द लोड कैरिंग कैपेसिटी چې कम दे هغه 401 دی सो बल सो کې एग्री कई anyone else with any opinion who would say that this column is going to carry the load 262 and who would say that this column is going to take load of 401? Anyone else with any opinion or anyone ji?
Sir, I think that this ये कॉलम दोनों लोड वो करेगा सर
क्या करेगा
क्योंकि हेलो
जी जी आप बोले ना हम आपको सुन रहे हैं आप दोबारा से बोल लें हमें आवाज नहीं आ रही हेलो ओके जी एनीवन एल्स इनके अलावा कोई बोल रहे इनकी शायद सिग्नल्स का इशू है Okay, let me explain. I don't know if somebody is listening to it or not. The problem over here is that we have got two directions, and in one direction, the load carrying capacity is 401, and in the other direction, it is 262, which is almost half of the other direction. अगर कि हम ये देखें कि 401 किप लोड हम डाल दें इसके ऊपर तो 401 किप लोड तो ये कॉलम लेगा ही नहीं बिकॉज it would have been already yielded in the other direction with a load of 262 kips. So it would have been already yielded in this load. So in other words, it means that the maximum load carrying capacity of this column is 262.5 kips. If we are going to load it any more than this, the column is going to yield in is going to buckle in the y direction. ठीक है ना? 401 की तो बारी ही नहीं आनी. It is never going to going to happen that 401 is going to be taken by this load. It is going to buckle at this 262.5 kips, so it won't have any more capacity to go ahead with this much load carrying capacity. And what I had mentioned in the start, that once the load carrying capacity or the P critical increases any more than this P critical, the load carrying capacity is going to start reduce right away. So this is the maximum capacity of this column. Right after this 262.6, if that is going to happen, the column is going to start buckling and it would reduce its load carrying capacity. Okay, so this is the maximum that it can carry. Okay, by comparison, buckling will occur about the y axis. The area of the cross section is 4.43 square inches. So we have already got this area of the cross section from the manual. So the average compressive stress in the column will be equal to sigma critical is equal to P critical divided by A. So over here P critical is 262.5 divided by 4.43, which is 59.3 KSI. Now, as we already know that the yielding stress for this column is 60 KSI, and it is going to fail at 59.3 KSI, which means that it is not going to be able to go to 60 KSI. Rather, it would buckle before that 60 KSI at 59.3 KSI. This is a very good design that this column is able to almost go up to the yielding stress by not having a thick section. 24 feet height is a lot more height for such a slender section, but still they were capable to take it up to that stress just because of bracing it in the lateral direction. Okay, just an insight of how the designs happen. Since this stress is less than the yield stress, buckling will occur before the material yields. Thus, P critical is equal to 263 kips. So, rounding off that 262.5 kips, they have rounded it off to 263 kips. And this is the end of this lecture. Anyone who's having any trouble in understanding, you can ask me right now. हेलो, कोई है? हेलो,
यस
जी
सर
सर जी
अच्छा, कोई सवाल है तो पूछें.
नहीं सर क्लियर है तकरीबन
तकरीबन
तक
जी
के
दलता
दोनों प्रॉब्लम्स तकरीबन
دا
है सर
solution کې دا solution تلاشه سر جی
solution ته راشه. په دې پوه نه شوم.
دا بل پیج تلاشه سر جی کنه مخکې پیج ته
अच्छा دا یو
او دلته ګوره د سر جی دا کیل ایکس په ایکس اکسس کې کنه 0.5 0.5 4 فوټ دا 12 فوټ راغلی دا موږ دې لپاره کوو چې دغه میټ کې دا 12 فوټ باندې دا هغه راځي یعنی دې باندې فشار راځي دې لپاره چې دواړه خواې فکس دي دې لپاره دا کار کوو
exactly, because both the ends are fixed, your k value is going to be 0.5.
ها دې لپاره دا دواړه د څه شوي لکه دلته کنه وای اکسس کې دا رقم شوی 0.7 باندې بیا ضرب کړی دي
y axis کې بل کنډیشن دی ګوره تاسو لږ आवाज بند کړئ چې تاسو وګورئ. دا ګوره په دې کنډیشن کې x axis کې د 24 فوټ هایټ دی. ٹھیک ده؟ په دې 24 فیټ هایټ کې دا اینڈ هم فکس دی او دا اینڈ هم فکس دی. نو چې فکس اینڈ د پاره مونږ دلته کې ویلیو زه لږ واپس ځم چې تاسو ته یاد کړم. the fixed end both ends fixed دی کنه
0.5
a is equal to 0.5 دی او یو end fixed دی او یو end hinge دی دا غي د پاره 0.7 دی نو اوس راشه دلته ګوره د فکس د پاره خو 12 نه sorry 24 دا ټوټل هایټ دی 24 ملټیپلای بای 0.5 which is equal to 12 feet ٹھیک ده په دې کیس کې څنګه چل دی په دې کیس کې دا ټوټل هایټ نه دی انوالوډ د برنه تر دې ځې پورې هنج اینڈ دی او د هنج نه بیا لاندې فکس دی ټیک ده نو هنج فکس او دا بره هم هنج فکس دی ټیک ده نو دلته کې مونږه غ 0.7 والا فارمولا به لګو خو په 12 فوټ باندې به لګو په 12 فوټ باندې لکه 12 فوټ هاف هایټ دی کنه نو هاف هایټ باندې مونږه سپورټ ورکړی دی نو 12 فوټ باندې دا فارمولا چې ولګي 12 ضرب 0.7 نو هغه 8.4 راځي
سر یو سلایډ تاسو پیچر شاته لاړ شي ٹھیک تھا سر
اچھا جی anyone else and this concludes our course for this semester as well inshallah those computer matic شو نو the assignments quizzes هر څه upload کوم 8 to 10 days بتا سول درکم according to the دغه کنه schedule چې موږ اوس next semester په هم start کوو دا سه نه چې ډیر زیات ټایم یې چې بیا رزلټ نشم تیار وو ٹھیک ده
او سر مونږ سره به د پیپرز کې چې کوم د آی ویلیو د او دغه ویلیو د دا به ګیون وی کنه
جی جی دا به زور کوم
ٹھیک تھا سر اوکے سر
thank you جی السلام علیکم
دا assignment په next week کې څه خبر شي سر جی
جی
assignment of quizzes next week کنه سر جی نو دا ډیر ښه ان شاء الله
ٹھیک ده جی اوکے